the working out.
Two minutes to the start. Do you all hear me? Okay. No. Does it look like? Okay, we start. Are you ready?
Hello.
Okay. Okay.
Hello, nice to meet you. We are come from Wonder Electric, Malaysia.
Nice
I'm
to know
Chris
you.
here. Fine, thank you.
I feel honored that such a competitor is there. By the way, sometimes the microphones give some troubles to the webinars. Therefore, if you have some questions, I would like you to write it down in the chat. And at the end of this explanation, I will answer to all of your questions, okay? Okay, so let's go. Actually, the main purpose of this webinar is not to explain how our products are. You can see how our products are in our web, therefore, I think it's some wasted words. But I'd like to explain mostly one issue: how ATEX are classified, how ATEX have to be chosen, what does this nomenclature mean, how many ATEX are there for you to choose the right one, for you to understand what the client needs, what the client wants, what the client should want, and also your client's errors, because often the client just read a nameplate, what is written there, and they puzzle you with such writings that make no sense. Sometimes they are classifications for Canada or USA. We are not there. While there are some other classifications which are there worldwide. Most of the international norms are following IEC scheme. IEC is authorized in Malaysia, like it is authorized in Latin America and in Europe, in Africa, and in Asia. And this is what we are following. We are not following NEMA norms, for instance. And we are also not following old norms. In past, even IEC or EN Euronorm, they were following different norms and different way to classify the motor. So sometimes we also receive inquiries of people who do not know anything about ATEX or EX. ATEX is more the European way of calling EX. And they don't know what they really want. They just say, please give him the same. Maybe that motor, that gearbox, that drive was the wrong one for them. Maybe they're spending more than what they really need. Maybe they're spending more and getting the wrong one, which is not solving their problem. Because maybe their problem is gas. Maybe their problem, and they are buying something which is for dust, just to make an example. But the problem is that most of the clients do not understand this nomenclature, do not understand these writings which are there on the nameplates, and they do not even know if that motor, that product was really suitable for their application. Now we are there to explain that, okay? And we'll try to do it in the easiest way by examples. Now, actually, I should not focus much about the European directives, but ATEX in Europe means atmosphere explosive. It's a French word. Explosive atmosphere with an explosion risk, okay? Which could be given by gas or by dust. And there are two kinds of directives. One is to teach to the manufacturer how to classify a product, and another is to teach to the user to choose the wrong one. Sorry, to teach to use the right one, not the wrong one. Actually, it is based, it's not made by this directive and most of all the norms. It is not made by people who studied law. It's made by people who studied physics and know the risks. Actually, when there is some explosion risk, these physicians were aware about the fact that in the atmosphere there was oxygen, and oxygen cannot be avoided because we are talking about workplaces. And okay, we could avoid oxygen to avoid explosion, but then we suffocate our workers, so they die anywhere. We cannot avoid the oxygen. We cannot avoid the fuel, because if we could, then we wouldn't be talking about this problem. I mean, you are in a gas station, a petrol station, you can't avoid the gas. But what we can avoid is heat or sparkles. This is what we have to avoid when we produce an ATEX product. And the ways to avoid, how much to avoid, what to avoid, this is what it is specified in the classification. And the classification is what you find written in the nameplate. Actually, the risk of being in front of explosive atmosphere is much higher than what people think. Once it was classified that 70% of the places where a motor, a gearbox, a drive is installed, it's a place having some explosive risks. Unfortunately, most of the people don't know it or don't want to know it. Why? Because they have to spend more, because the delivery time is longer, because we are, as human beings, enemies of the knowledge. We are lazy-minded. And actually knowing that there is a risk and that you have to manage the risk, you'd prefer to say probably, oh, nothing happened before, so it means there is no risk, but there is a risk. These physicians who made these norms in Europe, like anywhere, and I'm talking about norms which were born out of Europe and then they were transformed in Euronorms. So we are talking about like IEC, international norms. These physicians were not sadistic. They were really considering that there was a real risk. And since they were not sadistic, they also said, okay, but if the risk is low, you can make a product facing a low risk. Only if the risk is high, you need to get a product which is suitable for a very high risk. These are only examples of gases, by the way, okay? But here you can understand how many times your clients already are undervaluing or absolutely avoiding to know that there is a risk. For instance, a few days ago, we got a visit of a company making refrigerators, and they were not getting anything which was for ATEX. But I told them, look, but there is ammonia in the refrigerators, isn't it? Yes, it is there. Then it's ATEX. No, it's not ATEX, it's not ATEX. They didn't want to know. How to know if a liquid or a gas is, or a dust is risky, is ATEX? Well, there is Google. Just write ATEX and ammonia, and you will discover that somehow someone has already classified it, okay? The norms cannot contain all the possibilities. They contain examples. Because if, for instance, I am a plastic manufacturer, I make a new plastics with my own formula, how do I classify it? It cannot be written because it's my own formula. So how do I? You must go to a laboratory, make some tests, and then you can classify the risk of your plastics. And so with a lot of things. And the most undervalued thing is dust. Most of us think about ATEX like something related to gas, but you can't imagine how many places are instead risky because of dust, which could be, I classified 5 categories: wood and fibers, metals and alloys. For instance, most of people don't know that aluminum is flammable, but the smaller is the dust, the highest it is the risk. And the metals are, it seems strange, the most risky, because this is a conductive flame, which can be transmitted from one seed to another seed. Plastics, resins, and rubbers we can imagine. And there are also, of course, different ways to classify the risk. We will see that too in where we will talk about nameplates, classifications, and why you find certain letters written in the nameplate, and why you should choose A, B, or C. Agricultural product, there are a lot of things. Coal products, a lot of things. Even food industry, for instance. These are industries which are also just examples. Agriculture, offshore, drains and waste, paper, oil refineries, mines, food storage, textile. After this webinar, I will send you this document for your reminder. And since I'm recording this webinar, I will also send you a link to download a video, okay? And these are just examples. These are examples of gases instead of, or no, again, These are the same examples, but just the answer, sorry, to the clients, to the users who say it never happened anything, so why should I consider this risk? It's the same as before, but here you can see some fires. Fires happen, shit happens. And when they happen, they would like to come back in time and say, I remember when I said that the risk was not there. I would like to come back and consider it, okay? Well, actually, one of the risks is also that someone someday will make a control and they will say that this factory is risky before that something happens. And they give a fine or something else. I don't know in Malaysia how many controls are there, if they are there or not, and if a risk has to be assessed. But if something happens and you didn't act properly for this to be avoided, then you are guilty by law. That is worldwide. So better to consider it. Actually, we have 3 certificates because we produce 3 kinds of products: motors, gearboxes, and variable speed drives. Recently, 2 further certificates were issued by TÜV for our motors and gearboxes. That's because Alba Rubens, the first notified body, notified by the Italian ministry, who certified our products, stopped making this kind of work. And even if an ATEX certificate is valid for until the day that the products are changed or the norms are cancelled, nevertheless, we wanted to add some further features to our products, and because of that, we had to involve a new certification body and update the certificates. So now we can say that the motors and the gearboxes are double certified. With ATEX, a product needs to be certified by an external body, except if it is for a low-risk area. We will see what does it mean. There are 3 categories: very high risk, and low risk. With low risk, it's enough the declaration of conformity of the manufacturer. Nevertheless, you can make it certified. Actually, we make products which are ATEX for high risk, not for very high risk. I will show what does it mean. So this is what you find written in the nameplates of our motors, in the nameplates of our gearboxes, in the nameplates of our drives, and we will use these as examples to explain where we are and where we could be. And what does it mean if you find written 3 instead of 2? Why is it written G or D or things like that? So this is what you find written in our nameplates about motors. And we focus on motors because normally it's the most interesting one too for the clients. First of all, in the nameplates, we find this II writing. There are 2 kinds of writing that you find in the beginning, I or II, okay? I is for underground use in mines. And II is for surface industry. As you can imagine, 99% of the market is in II, where we are. If we were I and we were focused in a niche, then the writings on the nameplates were going to be totally different, okay? But we are in II surface. II is divided into, as we can see, 3 risk categories. If it was I for mining industry, underground, it was M1 and M2, the 2 risks. But we are in II surface, which means also mining, but if it is in surface, okay? It can be category 1 or 2 or 3. In our nameplates, as you remember, it was written 2. Category 2 gas. by the norm is defined as a place in which an explosive atmosphere is likely to occur during normal operation. And category 2 dust, it's a place in which an explosive atmosphere under a form of combustible dust in the air is likely to occur under normal operation occasionally. Okay? So it's not always there, but it can be there. Okay, that's category 2. What does it mean? I will make you some examples. It's important to know if it is category 3 or 2 or 1. You are holding companies, and a category 1 is much more expensive than category 2. Category 2 is much more expensive than category 3. So giving to a client a category 1 to say you are super safe, it's a good business for you, but the client sooner or later will move away when he will discover that he could spend much less if it didn't need category 1. Actually, sometimes the clients also don't talk about 2G or 2D. They just say, I want for zone 1, for zone 2, or for zone 21, or for zone 22. It's different ways to say the same, because category 2 gas is zone 1. Since category 2 gas, high risk, a product for high risk, is also suitable for an area with medium or low risk, then it is also suitable for category 3. And therefore, a 2 gas also suitable for zone 2. Category 3 gas is zone 2. 21, 22 is for dust. 21 category 2, 22 category 3. I will show you also GB means the same. G is gas, B is category 2. So if I tell you 2G, or they tell you GB, or they tell you zone 1, they are telling you the same thing. Okay? If I tell you GC, it means that they could also tell you zone 2. It means that they could also tell you 3G. I will go on with the scheme. DB, dust, B, category 2. Dust, DC is dust category 3 or zone 22. I hope that I'm not puzzling you. Okay, but the way I will review it once again in this table chart. Category 1 dust is zone 20, and we could find written DA. We have to find written DA in the nameplate. If we take, for instance, gas instead, category 2, gas is zone 1, and we should find written in the nameplate GB. So the client can tell you either GB or 1 zone or category 2 gas. 3 ways to say the same thing. Here you can see once again the description and some examples. Since we don't have a long time, I will leave the examples for you to be read. After that, we will make the webinar when I will send you these slides. Here we try to clarify what does 2G mean. Let's say that we are in a petrol station where the gas is always there. Like in the fuel storage tank, we are in category 1, which means zone 0. Where the gas is passing through to go into your car tank, that is, I mean the pump itself, that is zone 1. Gas, category 2. Okay, in fact, you will find it written in the pump. You see, surface, category 2, gas, That is what is written on the nameplate in the pump station. Okay, this is the European classification, but by the way, you will find that also the IEC will not differ. It's going to be surface, category 2, gas. Okay? And why do they tell you that you shouldn't switch on your lighter and smoke around the car when you are in a pump station? Because you are in the area category 3, okay? All around, where the gas is not passing through, but where it could happen that rarely it could be there, that is category 3, okay? Dust is the same. Inside the tank is zone 20 or category 1, where the dust, where the combustible dust is passing through, it's category 2, zone 21. All around, where the workers once again cannot smoke, cannot create sparkles, cannot do stupid things, that is category 3. Okay? So when you order a motor, a gearbox, a variable speed drive, and also some mechanical devices of any kind, an air blower, for instance, or a pump or something else, and this is conveying this combustible dust or this potentially explosive gas or liquid, that is category 2. Inside the tank is category 1. As you can imagine, inside the tank of benzene or the tank of a dust, you are not going to put any motor, any gearbox or something like that. That is why when we fulfill the category 2, we are facing the 99% of the market. In my personal experience, working experience, we have never been requested category 1 by any client, probably because no one thought that he could put a motor inside the tank of a benzene. Now there is something else written. We will also go to this EB, TB, what do they mean? But I would like first to explain what do C mean. Actually, this IIC means just C dust. IIC, sorry, C gas. IIC here in the second line means C dust. There are 3 letters which could be there. II or III are always there, but it could be A or B or C. And this depends by the physical characteristics of the dust, of the physical characteristics of the gas, how they have been classified, according to how they propagate the flame. For instance, a plastics dust, which is auto-extinguishing, is going to be classified for a lower risk than a plastics, which is propagate its flames. So they are classified by the norms in 3 kinds, A, B, and C. The C is the highest risk. So if a motor is classified for C risk, it means that it is also safe for B and for A. But if it is classified for B, it could not be installed in a place where there is a gas or a dust, which is C risk, higher risk. If it was A, it was suitable only for A and not for B and C gases and dusts, okay? And these are some examples of gases, how they've been classified. I'm sorry for them to be written in Italian, but you can understand, by the way, butano is butan, ethanol is ethanol, hydrogen is hydrogen, and so on. So hydrogen, for instance, is C risk, the highest risk. Hydrogen has also been classified for the temperature which can create the ignition. At what temperature does the hydrogen explode or get in flames? It is at T1 temperature, 450 degrees. So it's very high in risk for the way of propagating its explosion, but you need to reach a certain high temperature for this to happen. So T is meaning the temperature for the gas. When talking about dust, they didn't classify T1, T2, T4, but they classified by the numbers. But by the way, as you can see here in the corner of the slide, T4 means 135 degrees too. Okay, simply we are writing the same thing in two ways. It means that the motor, our motor, we declare, and it has been certified for, and it is nameplate for declaring that it will never heat internally and externally more than 135 degrees. So any gas and any dust which has an ignition point which is not lower than 135 degrees, any gas or any dust which gets in flames at a temperature higher than 135 degrees is suitable for our motor and vice versa. Okay, but if it was a strange gas, I don't find them here. I didn't find them, but there should be. Otherwise, why did these physicians who made the norms invent also T5 and T6, which is 100 degrees and 85 degrees? But if a gas exists, and I don't know which one, which is igniting at a temperature of 100 degrees or 85 degrees, then you need a motor which is not like ours. It should be with a rating which is T5 or T6, okay? But all of this, T1, T2, T3, up to T4, they are all suitable for our motors, okay? You may read in a nameplate T1, and we may be offering you T4. This is also a frequent confusion of a client. And the client comes back to us and say, no, I wanted T1. Why are you offering me T4? Because T4 is suitable for T1. No, I want T1. And now we start a stupid discussion. Sometimes we have this stupid discussion with ATEX because of ignorance. It's just like we make an IP55 motor, and the client comes to us and say, I want IP20. Okay, good. I'm offering you IP55. No, I don't want IP55. IP55 is not good for me. I want IP20, but IP55 is also fulfilling IP20. I want IP20. That is also the same stupid kind of discussion, but it's more frequent with ATEX because of there is more ignorance with ATEX. So when we say T4, we are fulfilling also T3, T2, and T1. Many motors are classified T3 in ATEX. And sometimes the clients is reading the nameplates and simply saying, I want something with this writing. And we offer something alternative and better, and they say, no, 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 no. Okay, now that is why we are here, to clarify this matter. So when it is T4, it is fulfilling all these classification, T3, T2, T1, but not T6 and T5. See about dust. Conductive dusts are the most risky. Metal dusts are the most risky. If your product is C classified, it is fulfilling also the requirements of B and A. It's once again like we did IP55, and therefore we fulfill also IP44 and IP33. Okay. So if you find that this dust is classified C, you can only get a C motor. If it is classified B, you can get also a B ATEX motor. If it is classified A, you can get any, because C, B, and A, they all fulfill with A. We are in C, and therefore we cover them all. And then there is the problem of the classification of a dust temperature. Once again, actually, I would like to underline also that when we write T 135 degrees, we are focusing in this case, unlike for gas, we are focusing in the surface of the motor, the surface temperature, okay? And actually, the dusts are used to ignite at a temperature which is quite high. Therefore, when we say that we fulfill 135 degrees, we are covering almost all the dust. These dusts are just examples, okay? Once again, I can only make examples because the possible dusts are infinite. Once again, any manufacturer, like a plastic manufacturer, can create its own dust, its own formula for its own plastics. So we cannot know everything. But we can make examples, and if one makes something or deals with something that has never been classified, it should make some tests to know that dust which properties has. And here we go to the most mistaken writings in motors nameplates. What do these EB or TB mean? Actually, this is something that we don't ask to the client. What does he want, D, E, or A? Once he has classified the risk, category 1, 2, or 3, once he knows that it's gas or dust, once he knows whether it is ABC, once he knows the temperature, he knows everything, doesn't need anything else. Any risk has already been assessed. So why is it written EB or TB? It's different ways, different solutions by which the manufacturer has fulfilled with all those risks, okay? It's just to say, you have classified the risk, you know your risk, you know your gas, you know your dust. This manufacturer has solved the problem in this way, okay? And there are many ways, alternative ways. Some ways are safer than some others, but the safety, the risk has already been classified. I'm suitable for category 2. I'm suitable for gas. I'm suitable for dust. I'm suitable for A, B, or C. I'm suitable for this temperature. So the solution is only a way to fulfill with all these risks. And whether it is EXD written or EXE written, you shouldn't care so much. In fact, there is different ways and protection techniques, as I told you. There is the technique of the containment, which means that if an explosion occurs, the explosion is kept inside the product, inside the enclosure. These products are normally made in cast iron, not always, but normally, and they are heavier. If an explosion occurs, it doesn't go out. It doesn't go into the atmosphere. Another way is segregation or encapsulation. Another way, which is our way when talking about gas, is the prevention technique. It means that the manufacturer shall find ways to avoid any possible source of heating, flames, sparkles, okay? Any possible source. Some people think that by looking at a heavier product, this is safer because it's heavier. But actually, I could also think that if the explosion is avoided in all ways, this can be safer. They can argue Okay, but if something goes wrong, the explosion it goes around. Something can go wrong also with enclosure. So the risk is always there. We try to minimize it. And talking about gas, these are all the ways: containment, segregation, prevention, as I told you, okay? Some are suitable for category 2 and category 3 as well. Some others are suitable only for category 3. Some others may be suitable also for category 1. Now, for example, the most classic motor that you have in your mind is heavy and in cast iron. That is suitable. It's the so-called EXD, okay? It's the most classic one. And that is suitable for category 2. It's not suitable for category 1. You cannot put it in the tank where the explosive dust or explosive gas is always there, okay? If you want it to be suitable for category 1, you only have 2 ways: encapsulation or intrinsic safety, okay? Increase the safety is our way at Motive. You find written EXE, that means increased safety. EXD is the most traditional. Both of them are for category suitable to reach category 2 as techniques. So these are the ways with whom EXD reaches the category 2 safety. Once we were also manufacturing this kind of products in cast iron heavy, but they were a bit too expensive, and furthermore, they were not suitable for dust as well. Actually, you remember there are 2 lines, gas and dust, in our nameplates. And that's because in the same Motive motor, we want to be suitable for either gas or dust. We don't have 2 alternative motors, one just for gas and one just for dust. One of the reasons is that we wanted to reach certain scale economies, which could make us more competitive. Another reason is that we wanted our distributors to find it comfortable to have in stock our motors, because only one stock could cover 99% of the ATEX market, no matter if it was T1, T2, T3, or T4, no matter if it was A, B, or C, no matter if it was category 1 or category 2, zone 1, zone 21, zone 22, 22. All of these had to be in the same motor, but EXD was not suitable for dust as well. We had to find a techniques which could permit us to make a motor suitable for dust too. We had to find a techniques which could permit us to make a motor also faster to be delivered and cheaper. And that is why we moved to a new way, the EXE, increased safety. EXE means that we have to do and control more things with EXD. Why EXD is the most classic way? Because it's easier. It's easier to think about designing a special enclosure. It's more difficult to think about any plastic material, the painting, the air gap between rotor and stator, the thermal dilatation, the impregnation way of a motor, and so on, all of these to prevent sparkle, flames, and risks. You have to keep in control the whole production and a lot of features. Furthermore, it's also more difficult to have a quality system suitable to do that, because when you make an ATEX product, it's not just a matter how you make the product in terms of technical characteristics, but it's also how you make it in terms of internal organization. You must be able to have a traceability of each component. And by a serial number, you should be able to find the chemical composition or the mechanical properties of a lot of critical components, like the terminal block, like the housing, the shields, and so on. What about dust? Actually, we adopted a way which is in this case the most classic one, which is to make a dust-proof enclosure. Of course, once again, this is not enough. We have to care about the paint, the cable gland, the external plastics material that should not have any anti-static charges, the paint thickness, the paint material. There are a lot of things to be considered when you make the risk assessment also for dust, even if basically the first characteristic is just not to permit the dust to come in, but then you have to care about the to take care about the dust outside, the external temperature and the anti-static charges. So the material of the terminal block, of terminal leads, the cable glands, and all the gaskets, and so on. There are also some tests in ATEX which are about the aging of a product. How long will this product keep on being safe? How long will the oil gaskets, for instance, keep on preserving this IP degree? If you want to know more about the main characteristics, which are not all, which distinguish our standard motors or standard gearboxes or standard drives from the special ones, you have to go into our website, into the, let's go to, sorry, here. You go to the download manuals. And then here you can download the ATEX addendums. For instance, let's talk about this, which is about the motors. This is called addendum because in Latin means addition, okay? This manual must be read together with the standard motors manual. These are the things to be added onto the normal manual. It is also specifying how an ATEX motor should be connected when you use inverters. And there is a page where, okay, where the main features distinguishing this motor from the standard one, where they are, which are they, okay? Here we talk also about something like shock resistance or air flow and things like that. Also, the manual has to be certified because when you make a risk assessment, you come to a point where you also have to inform the installer and the user how to install it and how to use. And therefore, also the manuals are certified. They are in the technical file that the certification body had to consider. Back to us, to the, oops, it was not this. We were here. Okay. So I repeat once again, the motors, the gearboxes, and the drives of Motive have been classified, have been certified. One of the future targets of Motive will be to certify the drives. Our drives are to be mounted on motorboard, also for gas. But just for dust, imagine how useful it is. In certain places like mines or farms, etc., they may find themselves in a in front of some risky dusts. And what they were doing before a solution like that, it was to have an ATEX cabin with ATEX cable made by someone making a risk assessment of that specific thing and put inside this special cabin a normal inverter because it was difficult for them to find ATEX inverters. Now they can have an ATEX inverter mounted on board of an ATEX motor, and they don't have to do all of that. But of course, you have to consider that if you mix together more products, the safety of this mix, like a gear motor, the safety of the gear motor is determined by the product in this mix having the lowest safety. So now, for instance, if we put together motors with a standard motor, with a standard ATEX motor, with an ATEX gearbox, we find a black cell here under the C. That means that the gearboxes were classified suitable for A and B gases and dust, not for group C. So if we make a motive ATEX gear motor, you will reach the safety just for A and B and not for group C. Like, for instance, metal dusts, okay? Well, there could be some further mixes like encoders, brakes, and things like that. Actually, the easiest way to understand what is the final result is to go into our website, look for, sorry, I have some problems with here, okay. Look for the configurator, come on, configurator, actually in English, okay. By the way, the languages here are so many. Okay, so let's stick in English. You say, I want a gear motor with a warm gearbox, and I want it to be with a motor like that. I want it to be ATEX. Okay. You will see that the only possibility, the only result will be with group A and B. Category 2, category 3, dust and gas, all these zones, but only groups A and B, because I put also the gearbox, and the gearbox is not suitable for group C. Then I may decide to put also an encoder. In this case, it will only offer to me an ATEX encoder, okay, and not another. Let's do submit, and let's see what happens to our ATEX. It's still also for the same groups because the encoder was suitable for group C. So we didn't limit anything. What if I also want to put a drive? Well, actually, this is something, a selection that I had to do from the beginning. So let's do it with another gearbox. Just to make an example, I choose this. I already know what I want. You know, if you don't know the configurator, you can also decide what you want by making a search by performance. You want 300 Newton meter? No, you want 500 Newton meter. You want an output speed which is 100, or you know that you want a motor of 4 kilowatt having 4 poles and so on. Then you classify the required service factor. It tells you, okay, then you have to choose this kind of robust, this size, having these things, okay? And then you say, I want it, sorry, I made a mistake because I forgot that I wanted the variable speed drive, which was the example that I wanted to make you. Just one moment. Let's try again with a warm gearbox. No, with a robust. Okay. I say, okay, let's keep this example. I want a 3-phase variable speed drive. These are all the possibilities. Submit. Okay, now I wanted ATEX. It will tell me that it's not suitable for dust anymore, my combination. It will not offer me anything suitable for gas, just because the drive is not suitable for gas. The more products I mix, the more limited it could be this classification, perhaps. Actually, the configurator will also tell me something like, you don't need to select the thermal probe because it's already standard in your choice, because you have chosen an ATEX. It will also tell me that, for instance, the IP65 is already there because you have chosen an ATEX. What is okay, this? You see, 65 is already there. We don't need to select it, and so on. Then I'm not going to show you here how the configurator works, as I often used to say, like to children, learn by playing. Back to our slides. So this is new. We had to widen our ATEX installation possibilities by including also ATEX encoders. There is an ATEX brake as well for category 2. In category 3, the brake motor would look like a normal brake motor with some specific features. But for category 2, we had to make an EXD brake. Okay, we had to adopt an EXD brake. In this case, it's cast iron, it's heavy, because the explosion had to be kept inside. Why did we do like that? Why is it like that? Because in that case, with you can imagine how the brakes work, it was impossible to have increased safety. We can't know how intensive is going to be the brake use. And therefore, it could generate a heating which was too high internally. The only way was EXD. So here we mix an EXE product, the motor, with an EXD brake. Why not? They are both suitable for the same risk category. They are both suitable for gas and dust. They are both suitable for ABC. Furthermore, the brake is hitting even less. It's hitting 100 degrees, and therefore it is suitable for even more gases and dusts. One of the last things that we added is it was the answer to some clients, mainly the Middle East, asking us, may I install your motor into an ambient having 50 degrees? If the ambient was hotter, also the motor was going to become hotter because of its normal temperature rise. Therefore, we couldn't use the old certificate, which was suitable only for temperatures up to plus 40 degrees. And thanks to the fact that premium efficiency motors have a very low temperature rise because of low watt losses, we could demonstrate by some tests, and we could make certify also the possibility to install IE3 in ambience of 50 degrees. So if you are going to install it in some places under the sun where you are afraid of a temperature that the motor could reach because of the ambient, then you could get this option. This is something else that we are developing to widen more and more the possibility to install our motors, ATEX motors, is to create power coolings ATEX. Actually, in the market, you don't find any power cooling maker which is offering you ATEX power cooling system. At least we didn't find, or maybe I removed this information from my mind because they were too expensive. So we decided to develop our own power cooling In this way, we use an ATEX motor as the motor for the power cooling. And so that makes it even easier to install it with inverters, with variable speed drives. In the nameplates of our ATEX motors, you find written for converter, which means that they're also suitable to be installed with variable speed drives. The problem is that, as you know, when you decrease the speed of a motor with a variable speed drive, you don't know how much the motor is going to heat. And therefore, in that case, you have to install a power cooling system. So if the inverter, the variable speed drive, was going to be used to decrease the speed, then in that case, the motor was not suitable anymore for the variable speed drive, unless there was a power cooling, and that is why we are developing it. This is something that is not very interesting in Malaysia, but we are now making, we don't yet have it, but we are making a certification for the Eurasian countries. And we are also making a certification for Ukraine. Last but not least, I told you before shortly, making an ATEX product does not mean only making a design and a production in a certain way. It also means to have a quality system, an organization which is more restrictive, more demanding than the traditional ISO 9001. Just to make an example, and that is only one example, we have to be able, from a serial number of a product, to go to the raw material chemical composition of all the die-casted parts making part of the enclosure, of a terminal box, of a terminal board, and many other parts. This traceability is quite heavy, but at Motive, luckily, it was already there also for standard products because of our digitalized organization. We have here barcodes on everything. And so for us, it was easy to make our IT system to manage automatically all this information, including the production lots, going to trace everything. And because of that, we could also get the certification. Sometimes the ATEX certified products are not supported by a company which is also ATEX certified. We were also like that. First, we certified the product, then we certified also our quality system. So our products were already being sold when our quality system was not yet certified ATEX. Okay? But because of our own responsibility, if something wrong happens, it's good that we can show that we did everything right. We can demonstrate that that product was right, not just in the technical features, but also made right without errors. So if you need further help, I remember you, use the configurator, which is combining all these features. And this is the end. Now, I'd like to answer to, this is not me, this is someone else, and it's not making it to you, but to the explosions. I go to the chat to see what was, which were the questions. And okay, good morning, I'm not going to answer. Any ATEX motor to have T5 and above? We don't have T5 and we don't have T6. Only T4, which means also suitable for T1, T2, T3. Ivan, leave your question, Giorgio will answer. Okay. Does Motive have a workshop in Malaysia to service explosion-proof motors? No. If we had it, we also had to make it be certified like we did in Italy. Actually, a distributor is not allowed to open an explosion-proof motor. okay? Because if he does it, he may damage some ATEX characteristics. And after that he did it, it should make all the final tests that we do here. There are a lot of tests to be done on ATEX motor, like for the rest of our organization, of our quality system. This is a standard for us, also a standard motor. In each motor, we have to test one by one, serial number by serial number, no matter if it is ATEX or not, but even it is mandatory. If it is ATEX, we have to check the grounding, we have to make the insulation test, the electric strength test, the resistance of each phase, and then we have a dynamic test where we have to check the rotation sense, the speed, the vibrations, the current of each phase, and the total kilowatts and the noise. And these are all the tests that we always do on each and every motor. Actually, I don't think that a distributor would like to make them. It's much better to keep in stock a ready motor. They have been designed to be suitable, I remember you, for 99% of the requests. And therefore, like one is stocking standard motors, it could also stock some ATEX motors now. Okay, he may say, but they are expensive. Not at Motive. Actually, they are very competitive. I know there is also Wonder listening to us. It's a very reputed competitor producing motors in China. And I don't have any problem in telling it. But I lost what I was telling. What I was telling?
You were talking about the motors and
yes, stock the motors because they are suitable for all the applications, all the ATEX application, 99% of them, and also because they are not very expensive. Normally, we have a habit to think that if we buy an ATEX product, just because we have a traditional point of view, it's going to be EXD, heavy cast iron. The explosion is kept inside, but as I told you, there are some other ways. And in our way, we were able to make our ATEX product cost only 30% more than the standard. Not the double, not 3 times, not 4 times, like sometimes it happens, but only 30% more. So if a distributor is going to stock our ATEX products, it's going to get also competitive advantage. Why I was mentioning Wonder, because even the Chinese, which are the most competitive price-based, they do not have so cheap ATEX products. So I would recommend the distributors to think about this business opportunity too. Stock ATEX products now. I saw it being done in Italy by a giant, but this giant has a product for category 2, one for category 3, one is for dust, one is for gas, one is for A, one is for B, one is for C. So I don't know how they can have a suitable inventory for all the possible requests of their clients. Probably they are going to offer mainly EXD or high-risk products for them to be suitable also for the low risk. But their high-risk products are made in that old way, our old way, which was too expensive. Do you have any further question? No. Okay, good. So, by the way, I don't have all of your email addresses. I will send the link to download the webinar recording to Ivan, who will forward it to anyone else. If someone is not known by Ivan, send your request to my email address that I'm writing down inside this chat, and I will forward you this registration. Okay? Thanks to all of you. Bye.
Thank you, Giorgio.
Bye.
Thank you. Bye-bye.
Bye-bye.
Thank you, Giorgio. Bye.
Bye.
Thank you, Giorgio.